So in a previous video, we talked about dealing with word problems that have comparisons or that are comparing two quantities, and we learned how to translate the English into algebra. So in this video, we'll do something very similar. We're going to translate word problems that also contain comparisons, but the comparisons are utilize fractions and percents. It's actually the process is very similar. We're going to do a lot of the same steps or the same two steps. And the keywords are the same. So if you see a word problem that contains more or less than, or greater or fewer than, or as many, much as, it's a comparison question. It's just that in these comparisons with fractions and percents, there will be percents or fractions involved. So let's take a look at these statements and translate them, and we'll follow the two steps that we learned in the previous video, which was step one was to assign variables, step two was to define the first variable in terms of the second. So this statement tells us that Adam has 20% more books than Gary does. This is a comparison, more books than Gary. We're comparing the amount of books that Adam has with the amount of books, or the number of books that Gary has. And our first step is to assign variables. So let's say that A is the number of books that Adam has, and G is the number of books that Gary has. So Adam's mentioned first, and we're defining A in terms of G then. That means that A is going to equal G plus or minus something, or multiplied by or divided by something. The 20% more means that we add 20% to G. So far, this is exactly the same as in the previous video, as in the previous method. The only difference is that with percents, you cannot have a percent by itself in a word problem. So when we're adding this 20%, it's 20% of something. And because we're defining the first variable in terms of the second, it's 20% of the second, in this case 20% of G. So when we're told that Adam has 20% more books than Gary does, we write that as Adam, or A, is equal to G plus 20% of G. And we can simplify that. G plus 20% of G, you can think of this as 100% of G. So A is equal to 120% of G. Let's take a look at the second one. In this statement, we're told that the number of bagels sold was 30% less than the number of donuts sold. So we're comparing the number of bagels with the number of donuts. This is a comparison. It's 30% less than. So I'll use B for bagels, D for donuts. Bagels is mentioned first, which means that we're defining the number of bagels in terms of the number of donuts. So we're going to be adding or subtracting or multiplying or dividing B. The 30% less than means we subtract 30%. So now the number of bagels is equal to the number of donuts minus 30%. Again, you can't have a percent by itself in a word problem, so it's minus 30% of D. Because we're defining the first variable in terms of the second, the first variable, the first item mentioned in the comparison is always by itself. It's on the left side of the equation, and then it equals to a whole bunch of other stuff on the right. Now we can do the same thing we did here as in the previous one. D is the same as 100% of D, so we can actually resimplify this or rewrite this as B is equal to 70% of D. And so that's a way that you can write that the number of, if you're told that the number of bagels sold was 30% less than the number of donuts, that means that B is equal to 70% of D. Let's take a look at the third one. So factory F's output is expected to be 140% greater this year than last year. What are we comparing? We're comparing the output this year to the output last year. We're mentioning this year first and then last year, so I'm going to use the variables T and L. So if the output is expected to be 140% greater this year than last year, that's a comparison, just using percents. We're defining the first variable T in terms of the second, so we're going to add, because it's 140% greater, we're going to add 140%. Again, you can't have a percent by itself, so it's 140% of last year. And this is our equation. So T is equal to L plus 140% of L. Just like before, we can rewrite this as 100L over 100 plus 140L over 100, which gives us that T, or this year's output, is actually 240% of L, or last year's output, which makes sense. If it's 140% greater, it's 240% of what it was. And finally, let's do one with fractions. So if a camera in store A costs 1/7 more than it does in store B, this is a comparison, comparing the price in store A with the price in store B. The more than, is the key word here. It's with fractions, but we'll follow the same steps as usual. A is the price in store A, B is the price in store B. We're defining A in terms of B, so A is going to equal B plus 1/7 of B. Again, you can't have a fraction by itself, so it's plus 1/7, but 1/7 of the second variable mentioned. And just like before, we can simplify this by writing this as 7/7 of B, and so now we have that price in store A, or A is equal to 8/7.